that it's not possible to cover all the previous year problems in this short-term course, but still I want to give you some material where I have written the handwritten, I mean, where I have solved the exams completely almost, and those solutions are handwritten notes. Okay, and material is handwritten notes. I would share that notes with you, and I would also share some document in which I mean, by which you can go to the videos. Let me show you how to do that. Okay, so let me present my screen. That what would be I would be sharing. So you will get this these notes tomorrow in the group. Okay, by tomorrow by 9 a.m. at least in the group. So this document contains the solutions, okay, TFR 2023, 2022, 2022, 21, 2020, 2019. These here are the links, okay. As you click on these, then you will go to the YouTube and you can watch the full solution, okay, of these papers. But I will also share the handwritten notes. So this is a document and this consists of, TF 2024 full solution. Please solve this, okay, because there will be a mock test tomorrow. You all know that. So it would be good if you solve all these problems. If you don't know the solution, then the links are given of each of the solution. Okay, so I would share this document in the group. So see, okay, answer key is also given there. So I will also share the handwritten notes of some of the years. Let me show them to you. Okay, so for that I have to present the screen of my iPad. So yeah. So give me 1 minute, okay? Yeah. So okay, I have handwritten solutions like this. So you can see that this is TFR 2020 2018 solution, for example, but I would be solving this exam today. In this way, some of solution of the sum of the years I would share also. Okay, please review all these. Okay, the solutions are handwritten. Okay, I have written these solutions, so you can review these. I will share everything. Okay, so get it these from groups of the Telegram group of Maths Aspirant. Of if you are in my group of Telegram, then you can get there also, right? So I would be sharing this now. Let's start today's class. Uh, okay, so I would today be solving TIFR 2018 exam. Okay, so yeah. But what I do today, I would first pose a question here from the TFR 2018. Show you a question and you will think for 1 minute today. Okay. Today I will give you time to think on each problem. Okay. And then tomorrow there will be a mock test at, I think I would fix timing. This would be around 7 or 8 p.m. So it will be announced in the group, and how you can appear for the test. There will be a tutorial video. Okay, so that how you can appear for the test. So before before appearing for the test, please review all the material what I have given to you. It will be helpful for you in the test and also in the exam. Okay, so yeah, give me 1 more minute, then I start the today's class. Okay, why I'm asking for this minute? Because I have to paste here the 2018 exam. Okay, so yeah, okay, so let's start. This is TFR 2018 exam, and we would solve this today. Okay, let's start from question 1. So I will give you, uh, chance to think about each problem. So let us solve first problem 1. Okay, so what this problem says, that this says that let A be a countable subset of R which is well ordered, okay, with respect to the usual ordering of R, where well ordered means that every in it. Okay, so then A has an order preserving bijection with subsets of N. So anyone? Yeah, think about it first. Okay, so do you know what does it mean, order preserving bijection? Okay, so let me tell you what does it mean. Okay, it means that suppose A is a subset, then if you have a bijection from A to N, order preserving bijection means that if X is less than Y, then you will get Fx is less than Fy. Okay, this means order preserving. It preserves order. Okay. So is this true or not? So what is the, I mean, something which is not in N? Try to think that it does not have a greatest element, right? So can we, think about a set A which does not have greatest element and countably infinite. Okay, so this set is this. Okay, dot dot, and I would add 1 here. So it has greatest element, right? Now we suppose that if there is a map A to N which is order preserving, which is order preserving, then every element, right, for all x in A, right? We have this. Every element of this A is less than or equal to 1. So then by order preserving property, we get that fx is less than f1 for all x in A, but which is not possible for any subset of n. Here it is written that order preserving bijection with a subset of n. But I have what I have written that f is a map from A to n, because whenever you have a map from A to some subset of n, then you can assume that this is a map from A to n, right?
Screen क्यों slow हो रही है?
No, but I think तुम्हारे साइड से कोई समस्या होगी. स्क्रीन विजिबल है. तुम्हारे पक्ष से कोई समस्या हो. आप म्यूट कर सकती हैं. आप शायद भूल गई.
लैपटॉप में रहने दो. टैबलेट में भी नहीं होगी. क्यों?
सिद्धि जय. आप अनम्यूट हैं, आप भूल गए. तो देखिए, so what I was saying that this should happen, right? Actually I forgot what I was letting you know. Yeah, so any map from A to a subset of n can be assumed a map from A to n. Okay, that's why I have written it here. So you get a contradiction because n does not have a upper bound. Although any subset of n does not have a upper bound, right? Any infinite subset of n does not have upper bound, because if f is a bijection, then its image must be infinite, and any infinite subset of n does not have a upper bound. So that's why this is not true. Okay, so this is a false statement. Let's move to the next one. Next one says that this is true or not. So you have to determine whether this limit exists, and if it exists is equal to 1. Okay, so I want you to do this. Okay, because this is, just finding limit. You solve such kind of questions in your 12th. And raise your hand once you solve it. Okay, let us do together. Okay, so what is given? That limit extending to infinity sin x over, we have to find this limit, right? So what we see that as, this is a 0 by 0 form or not, right? This is a 0 by 0 form. So L'Hospital rule can be applied, right? Let's apply that and see that what happens. Limit x tends to infinity, this becomes cos x if we differentiate it, because the differential coefficient of sin x is cos x. Okay, if you differentiate this, what happens? Then you get 1 tan x. And what is the differentiation of tan x? Let me know. Yeah, I'm genuinely asking, let me know.
Sec square x.
Sec square x.
Yes, sec square x. So this will be equal to. So now can you find that what is the limit? It is again 0 by 0 form, or now it exists? Just solve it and let me know. This becomes cos cube x, right? Okay, so this comes out to be, let me solve it, 1 plus 10x, and this is sec square x. Now apply x, put x equal to 0. What did you get? Then you get it's equal to 1, right? Can you see it? Yes, right. Good. Okay, so now because why I have taken this exam, okay, I could have taken the exam for solving full exam 2024, 2023, 2022. What I observed that if I take those exams, then it would take much of the time. It would not take, half an 1.5 hour. But I thought that I would give the material to you. I would share that, and you can watch yourself in free time. Okay, right? So that's why I've taken this exam, and also that because here are, students of those who have not much preparation, because this exam is on I mean consist mixture of the questions, difficult and some good question, some easy like this. Okay, that's why. But uh, yeah, now let's think about this one. So what it says, that for any closed subset A of R, there exists a continuous function f on R which vanishes exactly on A. Okay, it should not vanish on a point which is outside A. So question is asking about this. So solution, can we construct such a function that A is a closed subset? Okay. So, okay, it would I would happy to listen from you. Okay. Yeah, please. Kirtana, do you want to tell her? So try to think about a function which vanishes exactly on A.
So, can we
Huh.
split this one function into three parts?
Okay, who is speaking, by the way? I can't see.
Kirtana.
Okay, Kirtana. Yeah, let me know. So, what did you say? How can
Like,
we?
can we split it
Huh?
into different parts?
How can we? How? So how do we define fx?
Yeah, but I was still thinking. I actually forgot to put my hand down from the last question. I only considered it for like a closed interval. I
Oh,
haven't
right,
considered
right.
it for
In
finite.
that case, it would be easy, right? Because if you have a
Yeah.
closed interval, then you can say 2 to 3. Then what do? Then define such a function, right? Like
Yes.
this. So you can
Yeah.
define. But what can you do? Okay, take some motivation from this. Uh, what can you do? Okay, so we define this function, okay? Infimum.
सर ये ट्रू होता है ना सर?
हाँ, क्या होता है true? हाँ, true होता है.
सर वो जो कि सर ये ऐसा था ना कि सर आर से ऐसा सबसेट हमको बनाना पड़ेगा जहाँ पर ये फंक्शन वैनिश होगा. तो सर ये तो आर माइनस दोज पॉइंट वेयर एफ एक्स इज लेस देन 0 और union fx is greater than 0. So as af is continuous, so by neighborhood property fx less than 0 gives a open interval and
Okay,
fx greater.
so you need not to go so far. It's ये भी ऐसे कर सकते हैं इसको. See, fx define the distance function. Okay, distance function means we are taking distance of each point from a, right? Whenever a is inside a, then it comes out to be 0, right? So this function is continuous. Okay, this function is continuous. Okay, and defined on whole R, right? This function is defined from R to R. Okay, and it's continuous. Right? So see, if A belongs to A, then FA is obviously 0, right? Clearly, yes or no? See, because if A belongs to A, then what FA comes here, in this set, you would put some element, I mean, X is also some element of A, then A minus A would be 0, right? So this comes out to be 0. Infimum would be 0 in that case. So this vanishes on A, but what do we need? Are these only point where F1 is? Are there more? Right? Because if some point is outside A, then will may F vanish at that point? Okay, so how do we prove that? So what do you think about that? So in this case, what happens? See, suppose that Fx equal to this comes out to be 0, right? This is 0. So we get that the infimum of this set is 0, right? So infimum 0 means what we can do for each epsilon which is greater than 0, right? There must exist a point A in A such that this happens, right? Yes or no? This is the definition of infimum, right? Because if you take C, let me make you understand like this, okay? This is 0, okay? And we know that the infimum of this set is 0. So whenever we will add something to 0, say 0 plus epsilon, right? There must be points of this set, right? If not, then this is lower bound, right? If all the points of A above epsilon, then epsilon is a lower bound, but that cannot happen because 0 is infimum. Okay, so that's why. Okay, by the way, I forgot to turn on the video. Yeah, so that's why there must exist points from A, right? So what that is what I have written here. Okay, so for each epsilon there is a such that this should happen. So now can you conclude that this X is inside A? Right? Because we have assumed that for some X it vanishes, then this happens. So anyone, can you conclude that X must be inside A? This is true for every epsilon.
X is a limit point of A actually.
Yeah, good.
A is closed.
Yeah, good. So this shows that because this shows X is in A closure, right? But A closure is equal to A because A is closed. Right? So F vanishes exactly on the points of A. Okay, in this way we have constructed a function which is continuous from R to R and vanishes exactly on A. Okay, so this infimum function in fact is uniformly continuous function. Okay, and this is very important. Why? Because in TIFR I have seen that the questions from this function has been asked a lot of times, not only in this year, but also there is a question in 2024 year. So I will share that document, okay, what I have shown you in the starting of this session, that where there is a document in which solutions are also linked, so you can watch the solutions. Okay, I mean, you can review those questions also. If you don't able to solve yourself, just see the solution. Okay, so let's move to the next question. What next question says that yeah, so This is very interesting question, and this involves a very good construction, and you will learn something from here. See, whenever you solve TFR exam, right, then you learn a lot of things in CSIR net. You will see such kind of problems. Okay. And what I am going to let you know, right, we are going to solve this question, and the construction here will help you to solve problems from CSIR net also, because I have seen the questions like this in CSIR net also. Okay. There is a question in 2023 exam which is same like this. Okay. In the part C. So see, let f be a non-negative continuous function on R such that this thing is finite. Okay. Finite. But this limit does not exist. Okay, no. It says that this limit must exist and equal to 0. This is the statement. Okay. Suppose we want to counter it. So how do we, think about the counter example? How do we think? So we want to make, this, if we have a function, non-negative function, it must be non-negative first of all, because it is given, and continuous. So we want to construct a function which bounds, which covers the finite area, but its limit, and we want what I said, that I want to counter it. So I want limit to does not exist. So I want to make it something like oscillating when it goes to infinity. Okay. So, and it should cover the finite area. So how do I go? See. So I will define like this. Okay.
Thank you.
Yeah.
Thank you. Thank you.
What? Someone said something. Yeah. Yes, Siddhi, you are unmuted again, I think. Do you want to say something?
No, sir.
Yeah. Okay. So see, how do I construct such an example? Like this. Okay. This is very good construction. Okay. And such a question is also asked in NBHM. So and so on. Okay. So what we are doing that, and suppose that we have constructed this triangle has area A2, and let me call it A3, A1. Okay. And so on. So this graph of the function looks like this. So this is a non-negative function, right? In this way. This is a non-negative function and continuous. Okay. So the area of this function would be 1. Okay. The area of this triangle would be 1, and the area we won't make like that. Okay. And the area of this is 1 by 2 square, and the area of this triangle is 1 by 3 square. Can we do like that or not? You should understand, can we do like that or not? So how?
Yes,
So this
by
is
making the base narrow.
okay, right. So what is the height of each triangle? Height of each triangle is, okay, say height of n is height n. This is n, right? Okay. So we want an to be the area of an, I mean nth triangle. We won't make it 1 by n square. So what should we choose the base? Okay. So I also, let you know that, yeah, this is possible what I'm saying. Okay. So see, the 1 by square must be equal to, what is the area of triangle? Let me know.
Half into base into height.
Of BH, sir.
Okay. So we have the height, right? And we don't have the base. So it will let us know that what should we choose the base. Okay. So base would be like this, 2 by n cube. Okay. Make sure the calculations are correct. Okay. So I may make mistake. So now from here, you can choose the base, right? So just uh, keep this point like, I mean, you can do that, right? So here you have 3, right? So go just add the half of this number like this, and half of this number subtract it. So in this way, and then define the linear line, I mean linear function from here to here. So in this way, yeah, this construction is possible, I meant to say. Okay. So do you understand or not? I said some things roughly. Do you understand it? Yeah. Okay. So now see. So what is the area? I mean, what is this integral? ft. Now let's make the calculation. Okay. So let me write it by this color, green color. Okay. So the area is, can you tell me what is the area? I mean, what is this integral, right? This is just the sum of all these areas, right? Areas of these triangles. So this is area A1, area A2, dot, dot, dot. Okay. So this would be 1 plus 1 by 2 square, 1 by 3 square. So what do you think? This sum is finite or not? This is 5 square by 6, right? Yes. I have used this sum somewhere else also, right? In a question of countability. Yeah, I think you can recall that. So, but can you see the limit does not exist as x tends to infinity? Let me tell you, or you are going to let me know that limit does not exist as we go to infinity. What does it mean to limit exist? As we go to infinity and as x larger is larger, then we go close to some number, but that's not happening. See, so one thing is that we are going to infinity, right? Like that. 1, 2, 3. But other thing is that we are also going to 0. Yes or no? See these points, this. So if you want to show that limit does not exist, then what do? You choose some sequences. If I take the sequence this, xn equal to n. Along this sequence, fxn goes to infinity, right? Yeah, this shows that limit does not exist. This shows that limit is not 0. That's what I want for my solution, because it says that limit must be 0. But I'm saying that, but I'm saying more, that limit does not exist even. Okay, so if you choose this sequence, right, this is the point x1, this is the point x2, this is the point x3, then you say that the functional sequence fxn approaches 0. So limit does not exist. So this construction is very important. Okay, I mean the construction of this example is very important. Okay, so you have not tried. You can make this by yourself now. So what was our idea? We want the limit of function should not exist at infinity. So we want the limit oscillating and area to be finite. Okay. Then we start. So this is not true. This is a false statement. Any questions? Okay. So
hypothesis instead of a question. If it was uniformly continuous, then the limit would be 0.
Yeah, I think you can use some definition of uniformly continuous function. Then I mean prove that. I'm not sure, but I have to do solve that. Then I will.
Since the derivative would be bounded.
But the derivative need not exist of a uniformly continuous function, right? That's why. I think that might be true, but I have to solve that.
If it was given to be monotonically decreasing, then?
Yeah, okay, but if we would be discussing it's like that, if would be that, then we would not be able to solve this thing. Okay, what we are doing. So okay, if that would be monotonically increasing, then limit must exist at 0, by the way. And the monotonic increasing means the area might be finite or not. You have to think about that, but limit of the monotonic function must exist. And monotonic increasing, I mean, that's not
I'm saying
possible.
decreasing ना means मतलब मैं क्या कहना चाह रहा हूँ वो एक टेस्ट होता था कॉशी इंटीग्रल टेस्ट, उससे मेरे को आइडिया जैसा आया कि अगर ये 1 से इंफिनिटी होता इस टाइप का.
In the case of monotonic increasing, not possible, but
Decreasing,
if it monotonic decreasing that is finite, then this limit exists. Yeah, let me give think for a moment. Okay. Yeah, it must exist. Limit must exist for the monotonic decreasing function, but it need not be 0. Would it be 0?
कंपैरिजन मतलब एक कॉशी इंटीग्रल टेस्ट में इंटीग्रल और उसमें वो होता है ना कंपैरिजन सीरीज में. और वो हम x को इंफिनिटी ले रहे हैं.
But series is finite means that limit exists along the sequence n fn. Fn, the limit of fn would be exist, and it would be 0. Yeah, it's true in that case. Because the limits of monotonic functions always exist, and if we get the limit along some sequence, then it means the limit along every sequence would be that. Because in the case of monotonic increasing, you get the series converts, right? Series fn converts, but series fn converts immediately implies that limit n tending to infinity fn is 0, so the limit x tending to infinity fx is 0. Yeah, that would be true in that case. Okay, so let me move to next question. Okay, so but I suggest you to ask the relevant, because why? There is a reason, because if we would be discussing like that, but we would be stuck on some question. Okay, we would not be able to cover what we want. Yeah. So this. And by the way, you can join the Telegram group if you have some questions like what happens if this was this, what happens if this was this. I would be answering there. Okay, so there is a discussion group. It is given in the document I would share with you. Okay, so yeah, this everyone can solve this problem, right? So what I said in the last lecture, I think in the last lecture or last lecture, I said that there is a question in the TIFR exam which only asks that cos e to the power x is uniformly continuous or not. But I had already solved that, right? See, I mean, remember at that time. So this was already done in the last lecture. So let's not solve it. Okay, so move to the this one. Yeah. Okay, by the way, why TFR problems are too important, right? See, what do you learn from previous year problems? Let me tell you two things. Okay, one thing is that what I tell you about this, that this type of question is also asked in CSR Net in 2023, and this type of question is also asked in CSR Net in 2023. Okay, most of you will be appearing for the CSR Net exam, upcoming CSR Net exam, right? So that's very important to solve a TFR PYQs when you are appearing for the CSR Net exam even. Okay, but some of the students, what they do, they solve only the problems of that label which are equivalent to net from the TFR exam. No, it's not enough to solve only net problems of that only those problems from TFR level which mirrors the CSR net. Okay, you should solve completely, so that you solve some problems of higher level also, and you will perform good then in the exam. Okay, yeah, okay, so let me come back to the point. So this question. So by the way, I should ask you some questions, right? Today I'm not asking the questions. You might miss that, right? Okay, after this I will ask you a question. Okay, so let's think about it. Let A be a 3x3 real matrix such that a to the power 6 equal to I, then a square equal to I. So how many of you can solve it? Because see, when I say that how many of you can solve, you raise the hand, then you forget to blow the hands. Because when next time I ask the question and raise your hand, then I see that there are hand raised. But right, so I mean, remember to lower your hands also. Okay, Sarda, batao. Okay, so let me know. Okay, Siddhi. Would you like to answer? Yeah, you have raised the hand, right? Answer.
No, sir, I'm unable to solve.
Okay. So, Kirtana.
Because I was.
Kirtana.
Yes, sir.
So, what do you think? It is true or false?
It is true.
Why?
Because here it's given that a power 6 is equal to I. So
Okay.
a power 6 minus I is equal to 0.
Okay.
That is a is a root for x power 6 minus 1.
Okay.
That is the minimal polynomial of a has to divide this x power 6 minus
Right.
1. And
Okay.
it's a real symmetric matrix, which
Uh-huh.
means it has real eigenvalues.
Okay.
So if I am finding
Yeah,
the minimal
correct.
polynomial of a,
Okay.
it has to be x minus 1, x plus 1,
Right.
or
You are
x
correct.
square minus 1.
Yeah.
And whichever case you take, in all of these, it satisfies a square is equal to I.
Right, right. You understand. So, see, right, you are very right. Okay. So we see that x to the power 6 minus 1 annihilates. One thing I want to let you know all that whenever there's a given matrix, okay, and some polynomial is given, okay, that it satisfies this polynomial, then always this works, okay. Not always. I mean, this what we do that the polynomial, suppose you have given a polynomial fa equal to 0, okay, then the fx annihilates a and the minimal polynomial divides fx. This thing works. Okay, try to apply that in whenever you see a polynomial in matrix A. Where sometimes the questions like this, where it is given that A satisfies some polynomial, it asks about the diagonalizability and the minimal polynomial with, gives the information about it, right? So you can always apply this type of thing, okay? So mx divides x6 minus 1. But what is the factors of x6 minus 1? X cube minus 1, x cube plus 1, right? So this comes out to be x minus 1. So what is the, I mean, irreducible factors? Can you tell me? What are the all irreducible factors?
X
So
plus 1, x minus 1, x square plus x plus 1, and x square minus x.
Is this correct? Is this correct? Okay. So see, the possibilities of minimal polynomial must be real, okay? Minimal polynomial must be real. So minimal polynomial, we can say that divides x square minus 1 from here. Because that must be real. Oh, right, real. Minimal polynomial must be real and also should have real root, at least one real root. Okay, because this is a 3 cross 3 real symmetric matrix. Because M should have a real root. Real root, right? Because at least one eigenvalue should be real, right? By the way, all the eigenvalues should be real because this is a real symmetric matrix. Yeah. Because it might happen, right? You can say that minimal polynomial can be this, sir. Yes or no? Because what I said was I said that it must have a at least one real root, but that does not imply this. Okay, all eigenvalues should be real is the reason for this. All eigenvalues should be real. values are real. Okay, because a real symmetric matrix has real eigenvalues. Because if you see, if something like this appears in mx, then it implies that it has complex roots also, because these non-real complex, okay, these factors has non-real complex roots. So what does it mean? It means that a square minus 1 I equal to 0. That means a square equal to I, right? Yes or no? Because x square mx divides means mx times qx. Okay, when you put a, then what do you get? ma qa. So ma is 0. So a square equal to I. Okay. So there is a question, same question in CSR net. Okay. Of 4.75 in, I think, 2023. December 2023. Okay. Maybe, or maybe around that. So, and by the way, you are solving TIFR 2018, right? So you see this question, this of what I said, that there is a same question. I mean, if you will solve this question, then you can solve that question in CSR net. And this type of question is also there in some 2023 exam. Okay, so when you learn questions from different exam, then you will definitely be performing well in different exams. Okay, so yeah, so I need to uh, charge my phone. Sorry, I need to charge my iPad. So till then, let me give you a, okay, let me pose a question here. So from which area you want question to be posed? Okay, anyone, okay? You can say any area, I will pose a question. Good question, Romy. And you will think about it. Real, linear, abstract, ring?
Real, sir.
Okay, real only. Okay, so real and
Say rings too.
rings too. Okay, so someone will say, sir, linear also, right? Because
Linear.
different persons had different opinions. No, not all can agree in
Real.
one thing. Okay, okay. I will pose 3 questions. Okay, don't worry a bit about that. Okay, so see, suppose f r to r be a function such that for all monotonic xn converging to a, fxn converges. Okay, then this is true or false question. Okay, then f is continuous at a. This is for real a. And someone said ring theory, right? Ring theory. Okay. Ring theory. Do you know Noetherian rings? So who said ring theory? Do you know Noetherian ring? Okay, let me tell you. A ring in which every ideal is finitely generated. Okay, because you see that Z is a Noetherian ring. Every ideal is finitely generated here. 2Z, 3Z, etc. are the ideals, and those are finitely generated. So the question is that, does there exist a subring of qx in which, I mean, there is a non-finitely generated ideal, okay? Or you can say which is non-Noetherian, which is non-Noetherian, okay? Or suppose R is a domain such that either x belongs to R or x inverse belongs to R for each, okay? Here x belongs to k is fraction R. Do you understand this question? R is the integral domain, and K is its field of fraction. Then you have no. Question is not complete yet. So either X is in R or X inverse in R. So then R is local. PID. So this is, you have to tell true or false. Okay, true or false. And someone say, don't you want question from linear? Okay, so that's enough for you. If you want, then I will pause here. Okay. Just say you want some question from linear. Then I think that the students are interested. I mean, in the questions. Okay. So which topic? Let me know some topic. I will give from that.
Canonical form.
Linear.
Jordan canonical form.
Yeah.
Okay, someone said something else.
Diagonalizable, sir.
Diagonalizability. Okay. So right. Okay, let me write a question. Canonical form. Okay. So okay, the diagonal, I can give you a mixture of the question, okay? For both the questions, diagonalizability and Jordan canonical form. Yeah. So suppose right, X belongs to R cube. Okay. And A is symmetric. 3 cross 3 matrix. Indefinite. Then there exists a Y not equal to 0 such that Fy equal to 0. Okay. Indefinite means, do you know? Indefinite means which is not positive definite, not negative definite, it's indefinite. Okay. This proof can be solved using diagonalizability and also Jordan canonical form. So okay, till then, why I was taking a break to charge my iPad. It may get switched off. By the way, tomorrow you will see very, very good questions in your exam, okay? In the mock test. Yeah. So can anyone of you think about these questions? Okay, so raise your hand.
Slight doubt in the first question.
Okay, so what is doubt?
Sir, fxn is convergent, or we also know fxn is convergent to fa.
No, it just converts. It doesn't need to be converged to fa. At least one question solved, please. Solve at least one. And raise your hand if you do. So Sagnik, which question did you solve?
Okay, I have thought about the first one. I mean,
It might be true or not. First, let me know about
I
that.
think it is false.
Okay. So Dhruv, did you solve some
Sir,
question?
I also think it is false.
Okay, you also think it is false. And I want that I want you to think that it's false, but it's not false, okay? And I mean not you only, okay? No, all. I mean I have constructed the question in some way that it might feel that it is wrong, but it's not wrong really. I mean it's not false, okay? Yeah, it's not false. Okay, Arun, did you solve some question?
Yes, sir. First one.
So do you think it's false or
Yes,
true?
sir.
It's
I
false.
think false. Yes, sir.
Okay. Still you think it's false. Okay. Siddhi, have you solved also? You have raised your hand also. Okay. So Ria, which question did you solve?
Sir, it is
So
right.
third one.
Third one. What was the third one? Okay, it is true or
True.
not?
True.
Okay, fine. Okay, fine. So student, first one is false or true? I said that I want all of you to think that it's false. It might be false. So, or you think that it's true? Okay. Let me leave this question unanswered. By the way, I have already answered. It's true. Okay. Think about it. So why, if you think that it's false, you can give me counter example. Do you have anyone? Do you have the counter example?
Sir,
Yes, sir.
discrete function, 1 for rational and -1 for irrational. Then every action converts to, but it is not continuous.
Okay. Yeah. Okay. So fx is equal to 1.
Sir, 1 for rational and -1 for irrational.
Okay. So okay. So which is what is the point A? Point A
Sir,
is
it is for fixed point. I am taking for every point. If action converts to any point, like for 1.
okay. You can take any A, but give me some A, right? You want to counter it. So show me that there is a where for every monotonic action, fxn converts, but that is not continuous at A, right? That's how you
We
counter
can
something,
do
right?
0.
0. Okay.
0, sir. Yes, sir.
Okay. So see what I'm going to do. I'm going to take a sequence x1, x3, which is of entirely rational numbers and converts to 0. That I can do, right? Yes or no?
Yes, sir.
And now I am filling irrational numbers x2, x4, and this just consists of entirely irrational numbers and goes to 0. So what do you think about this monotonic sequence? Xn. Will it be convergent? No, right? It will not convergent, right? Because it will comes out to be 1 minus 1, 1 minus 1, 1 minus 1 like that, right? Yes or no? Do you understand?
Yes, sir. Yes,
So
sir.
it would not work. Okay. Yeah. So yeah, by the way, you all are trying. That's very good. So yeah. Okay. So let me move to the other questions. I will ask. Yeah, Dhruv, do you want to answer?
So as I also had another counter example. I don't know how to prove it is true.
No, I mean, how to prove that counter example is true? What do you mean? Then how this
I had a
option is
counter example to show it is false.
okay, but you don't know that how to, prove that that's true counter example.
No,
No, so when you say that you don't know how to something.
I don't know how to show that. Right now, I have a counter example, but the statement is actually true. So there must be something wrong in my counter example. I don't
Oh,
know
but
what's
you
wrong
don't
with
know that where is the flaw, right? In your counter example. Okay,
Yes.
let me know about it.
Yes.
Okay, let me know about.
So the signum function.
Okay, signum function. Okay. Yeah, so signum function, right? So at what point it is not continuous?
0.
So how this is working as a counter example?
Any monotonic sequence, if it is, again, I'm not assuming strictly monotonic. Either it is, if it is increasing, it will have to go somewhere before -1. Or if it is decreasing, it will have to stop before, like after 1, or it is eventually constant.
Right, right.
So in that case, we are getting, in each case, we have a convergence.
So you
Because
want to
they are three separate
okay, you want to take the point 0 and say that suppose we have a sequence xn such that xn right. I think I should add something there that fxn converts to fa. Right. Yeah, thanks. You are right to point it out. Right. I should add it. That would work otherwise. Because from either side, if you go to 0, so suppose that if you go from left, then that would be, always convergent, right? Because that would be giving you -1. And from the other side, that would be giving you 1. Right. Yeah, I should add here it. That fxn goes to fa. Yeah. That's important. Yeah, thanks. Then it would be true. Okay. Good. Very good. Okay, so let's solve this question. Okay, see, this question is asked in TIFR 2018. Okay, so but in the CSR net, same question is asked in 2019 part B. You can check, okay, if you don't believe me. So in the vector space F, this vector space of real valued functions on the closed interval days, the set is linearly independent. So what do you think all? Yeah, solve yourself. Okay, raise your hand. Okay, very good. Some of you raise the hands and I want others to try also. Okay, yes, all the students and let me know. Raise your hand. So it's not that difficult, okay? Try. If you won't try, then if you are thinking that, oh, I would not be able to solve it, this is something very different, please try. Okay. It's very important that you would try. If you don't try, then how would you learn? Okay. अच्छा मतलब हाथ ऊपर करके भी नीचे कर लोगे क्या हुआ सॉल्व करके नहीं सॉल्व किया हुआ कैसे हो गया so I mean once some of you raise hand then below why okay so Kirtana what is your answer
It's true, sir. They are linearly independent.
okay so you are UG or PG student
UG student, sir. Third year.
okay Okay, very good. So very good. You are solving very question. I mean,
Thank you, sir.
right. Good. So happy to see that. Okay. So you have given sin x, cos x, tan x. Okay. So you are asked that these functions are linearly independent. Okay. This is very, very straightforward. See. Okay. Let's assume a linear combination which is equal to 0. That is the standard procedure, right? How do we check that some set is linearly independent, some finite set is linearly independent? So considering a linear combination which is equal to 0, then if this would be linearly independent, then this must imply that C1, C2, C3 equal, all these are equal to 0. Okay, so but this should hold for all x. Okay, for all x belongs to 0, closed interval 0, 1, right? I mean, if some function is equal to 0 identically, 0 function, let me write it here, this symbol, identically 0, then this should hold for every x, right? Now try to put some values of x, right? So that you get at least 3, 4 equations. But that would imply that C1, C2, C3 are 0. Because you have too many values of x and you will have two, equations more than unknowns. How many unknowns are there? 3 unknowns, right? I mean, you will have equations like that, alpha 1, alpha 2. No. Yeah, right. So suppose you get the yeah, something like that, C1, C2 equal to 0. What do I mean to say? That you can pick particular values from the closed interval 0, 1. Okay. So you can take less pi by 6, then you can take pi by 4, you can put pi by 2, okay, and you can get pi by 3, right? Then you will say that the C1, C2, C3 must be equal to 0. Yes or no?
Sir,
Huh?
sorry for interrupting. I just wanted to point out we can't give pi by 2 and pi by 3 because our function is defined from the domain 0, 1.
So
The values
it's,
of pi by 2 and pi by 3 are greater than 1.
yeah. Thank you. I was also thinking that. Right. Yeah, it's very good to point out that. Right. So you can choose other values, right? Good. Pi by 4, and what can you choose? Pi by 8, something like that. Okay. But think, right?
0,
You will, huh?
0, 0.
Yeah,
0,
0.
sir.
Oh, that is very important value, right? How can I forget that? Okay, that's very important because once you put 0, this would be 0, and this would immediately implies that C2 would be 0. Then you will have a relation only in C1 and C3, then choose the values. Okay, right. So you will do it, or I have to calculate and so you will do it, right? Now, 0 is very important. Okay, I should start here. By the way, you can write, you don't have to put all these values. Okay, suppose you have 3 unknowns and 4 equations, say 10 equations in 4 unknowns. Say you have unknowns like this. You have a matrix of this like this. Okay, you have this system. So what do you think about this system? 0, 0. What do you think about this system? It has non-zero solutions. Why it should have non-zero solutions? Suppose you have a system of linear equations that A is a 10 cross 3 matrix, right? It means you have 3 unknowns. Then why do you think that it has non-zero solutions? Let me know. The solution must be 0 or it should be non-zero. there must always a non-zero solution. Yes or no? The number of linearly independent solution is given by n minus rank, right? Okay, in the this would not work. Okay, yeah. What I'm saying that this would not work to determine that the all C1, C2, C3 because C0, because it can have, you know, if you would n minus r, then the number of linear independent solution can be 1, 2. Yeah, in that case you can get a 0 solution, right? Sorry, actually I was misunderstood something. So you do put first the 0 value and then you get the relation in this, because in that case you get C3 equal to 0. So let me tell you how in short you do this. Now put pi by 6 and pi by 4 and get that, make the system and get that the determinant of A is non-zero. So C1, C3 is 0. Okay. So that's how you do it. Yeah.
Sir,
so someone said, sir. Yeah.
Sir, I did by proving that the Wronskian is non-zero at some point. Like for Wronskian of pi by 4, this is actually non-zero. So that's how I proved it.
Yeah, but that when you prove that thing about Wronskian, that involves this thing, linear algebra. Yeah, but you did right. Okay. Yeah. Good. That's good. So, okay, let me move to the next question. By the way, I don't think that we would be able to cover this full exam, but I would send the handwritten solution of this exam. Please review that, okay, before appearing for tomorrow's mock test. I would write, I have written full solution of this exam. So don't worry if you would not be able to cover it. I definitely would not be able to cover it. So, okay, now let's go by question by question somewhat fast. Okay, so let f be a twice differentiable function on R such that each f and f double dash are strictly positive on R, then the limit extending to infinity fx must be infinity. So the easiest example is this. Okay, fx equal to e to the power minus x, because when you x tends to infinity, then e to the power minus x tends to 0, does not tends to infinity, and it also satisfies that f and f double dash are strictly positive, because f and f double dash in that case are just e to the power minus x. Okay, yes or no? Right. Okay, so now the next question. Okay, now if something question would demand explanations, then please see that on notes. Okay, I will send it to you. So I will not solve it here. Then if G, let G, H, because we have less time now, G and H be finite groups, then any subgroup of G cross H is equal to A cross B for some subgroups A of G and B of H. By the way, yesterday I let you know about a result that says that the ideals of R1 cross R2 are both are rings with unity, commutative ring with unity. So in that case, the form of the ideal is I1 cross I2. But what about groups? If you have two groups, G and H, you consider the direct product, then it is always true that all their subgroups are of the form A cross B, where A is a subgroup of G and B is a subgroup of H. So what do you think about this statement? So sometimes I doubt, are you involved in this discussion or not? You should think about it.
Actually, no, this is not true.
Okay, not true. Raise your hand if you know the answer, okay? Every time you can raise your hand if you know the answer. I can ask you. I won't make it interactive, just not a one-way lecture. I'm speaking and you are just listening. Okay, we should enjoy this, right? Okay, so by the way, I would like to ask you, Kirtana, you have raised the hand. So what do you think? Is it true?
It's not true. It's false.
It's not true. Why it's not true?
I can give a counter example.
Give me a counter example.
So let G and H be Z3.
Okay, Z3, then?
Z3. So it's the subgroups of Z3 is just singleton 0 and Z3 itself.
Okay, good.
So if I take all combinations of A cross B, I'll get 4
Then,
subgroups.
but you can show that there are more than 4, right?
G cross H has 6 subgroups.
Okay, very good. So you can even take Z2 cross Z2 or not. Can you take Z2 cross Z2? Would that work?
Yes, I believe it would.
Okay, so how many subgroups of Z2 cross Z2 are there?
5?
5 or only 4? Yeah, 5. Right. Very good. So there are 5. So if you assume that all the subgroups are of this form, A cross B, then there must be exactly 4 subgroup. Or you can directly say that just take this, okay, diagonal subgroup. It is called diagonal 0 0 when both the tuples are same 1 1. This is not of the form A cross B. You can check that. Now let me pose a question here. What question I'm going to pose? Okay, so whenever you are going to counter such a question, then you will give me example Z cross Z, someone will give me example Z3 cross Z. But suppose that G1 and G2 are 2 groups, okay? And G1 is not isomorphic to G2. So then result will hold or not? Do you understand the question? That G1 and G2 should not be isomorphic. Then what do you think about the subgroups of G1 cross G2? Okay, don't, you know, I mean, yeah, first let me know. Sagnik, what is your answer?
No, it still won't hold.
Okay, by the way, what is the example?
Suppose, I mean, I'm speaking generally. Suppose G1 and G2, suppose there is a prime which is dividing order of both. So take an
Order of
take an
both.
element. Yes.
Yeah, order of both.
And
Then
they have a common prime factor. That's what I mean.
so
take
so
an
what?
element of order P from G1 and take an element of order P from G2. Let's call them A and B. So the tuple A comma B, the cyclic group generated by the tuple A comma B, will not be of the form of that form A cross B.
Why?
I wrote it down that.
Okay, fine. But what happens if there is no prime? Okay, right.
Example would be, we need the common factor, common prime factor 1.
Okay, right. But
So
now let me, right.
Z2
So
cross Z4 can work.
Okay, but what happens if there is no prime which divides the order of both? The GCD of order C is 1. Then what happens?
Then the result is true.
Why? Why result is true?
Actually, sir, I have studied Gauss-Seitz lemma.
Which lemma?
Gauss-Seitz lemma, which classifies all the subgroups of G cross H.
Okay, good. So, okay, think about all. You can think about it. Okay, so now let me move to the next question. This question 10. This is asked in where it is asked? CSR net. Which year? I can't recall that. 2024, 2023 again. So those who are setting the exam are looking at this exam. There are too many questions from this one, right? No, they are not looking at this. Okay, I'm just kidding. So by the way, there are too many questions in 2023, right? So and this also 4.75 marks in the net. Okay, so yeah, how do you solve this? Let me tell you, I have written down the solution. You can check in the handwritten notes. Okay, but first of all, its limit is 0 and try to apply the MN test. The infimum achieved in a fix A, which is okay. Let me tell you how do you do that. So consider MN equal to the MN would be like this. So so that the infimum is achieved at a which is independent of N. Okay, and lies between this. So the infimum is this. Because it cannot be achieved at 0 and 1, okay? Because at 0 and 1, this function x and gx is going to give you the 0 value, right? Because at 0 and 1, what is its value? Its value is 0. So the supremum, oh, if I call infimum, sorry for that, Mn is supremum, okay? Mn test, supremum over 0, 1, okay? So let me write it short. Supremum over 0, 1. So it is achieved at a which is satisfying this. Then as n tends to infinity, this sequence go to 0, okay? In this way, this is true. Okay, but for full solution, you can check it. Now this you can do, okay? For this also, you can, now all the questions you can see, okay? So let me show you that handwritten notes, okay? The recent, yeah, oh, this is not that one. Because now it's time to stop, okay? I have solved it here, all the questions, okay? You don't need to worry about that. We should not cover here. It is in very detail, not like that. Because in the crash course, I am going fast, right? But usually I do not teach too much fast. So here I have written in detail and in very good handwriting though. So you can watch it, okay? I mean, you can look at it. Watch it means you can, if you want to watch the video solution, then you can use watch the video solutions also. I will give you the link here. I think I have solved all the questions. Yeah, definitely. Yeah, last up to 25. So see, now I think we should say goodbye to each other. But before saying goodbye to each other, let me tell you that there is a mock test tomorrow. Let me remind you. So what is the procedure to appear for the mock test is that there will be sent a tutorial video, okay, of 1-2 minutes. You have to download some app, and on that app, how do you appear for the test? It will be there will be a video which will be sent to you by tomorrow at 12. Okay, initially I said that by 9, but I don't think that that would be possible by 9, but it would be sent to you by 12 PM tomorrow. Okay, so wait for that, and that's very easy. Okay, don't think that it is very complicated or something like. You can just have to download some app from Play Store, and then go to that app and you can join the test. Okay, but there is something that how would you choose options? Okay, because there would be 5 options, and for true or false, what you have to do. Right, where you have to click for true, where you have to click for false. That would be told in a video. I would be letting you know about that. So I will send whatever I said by tomorrow PM. Okay, the material what I was talking about is starting of that this session. Okay, yeah. So right, I would stop here. So anything you want to say from your side?